I love this amp and I hate this amp. Well, we're back for part 2. About 5 months ago, I received this amplifier. Guy sent it up to me, told me a huge story. It was a sad story. The story on this amp is that the guy used it every day for about 24 years, used it 3 to 5 hours every day for 24 years. And the old tubes, which I have over here, I can talk and walk at the same time. Let me go over here. The old tubes that were in this thing are these here. These precious little gems of death right here. Well, he ran the box and he never once looked at, this is your high voltage, this is your grid meter. He never looked at the grid setting. He just tuned it out and left it and talked on it every day. Power drop off a little bit, you just reach over and hit the power button, raise it up a little bit, and come right back and keep going. These tubes we tested in the first video, which I will put in the description down below. Can't hold anything more than about 600 volts without shorting over. And these are the ones that we sat there and watched internally on the porcelain here, the glass arc, literally like a welding arc on the inside of the tube. They got to the point where the tubes completely broke down and just gave up the ghost. And in the process of that, the high voltage, when it did finally, the tube finally did start break down and lost its ability to insulate and isolate itself. The high voltage blew up a bunch of stuff, and we covered that very thoroughly. Well, he come along and I told him, I say, man, I'm going to go out there, I'm going to kick the tube tree, basically kick YouTube. And nobody came to us with a good set of tubes. IMAX, American made, high quality. He went out and he purchased himself a set of new tubes. They came from a wholesaler in Arizona, and they're Chinesium. You can beat around the bush. They were just Chinese tubes. Well, I thought, well, as far as I could tell, I tested everything I could on the inside of this box. And boy, howdy, I tell you, I thought we were good to go. And then we went to run it, and then we lost key pedal action, as in like when I'd step on the foot pedal, that quit working. Then it was acting like the bias was fully engaged. And, well, we turn the amp on, just like we did here. Oh, and the light bulbs. I didn't have the right voltage light bulbs. Obviously, I have the right voltage light bulbs now. Shabba! Fixed. Ooh, look at me, I changed some light bulbs. Where I left off was that there was some problems in the bias circuit. And boy, howdy, was there ever. I had components that were failing in operation but weren't breaking down on the tester. Had 2 transistors. I'm going to show you which ones here in a minute. But the main problem was that we turned this on, and about 30 seconds to 45 seconds into the thing taking off, the tube would start to heat up, and all of a sudden it'd start pulling a bunch of amperage, like the bias was engaged. But we'd come over here to the grid meter, and we'd have 0 on the grid. So I was like, oh, well, that's a bias issue right here. What I didn't realize is how much current it was actually pulling. It was bad. I just thought it was a bias issue. So I went and I drilled in on the bias circuit. Well, we had 2 transistors that failed. And it wasn't until tonight I was able to figure out what the other things happened over here in the power supply. Now, please note, if you ever run your amplifier like this, you have a death wish. This is not safe. Electricity will kill you, boys and girls. It'll kill you deader than snot. Like, you're dead. Your wife, girlfriend, kid comes out and they find you dead because you ran it like this. Every safety interlock that, TenTec has put in place by law that they have to put in here, I have bypassed for your visual satisfaction. Do not ever run your equipment like this. It will kill you. So just think because I did it doesn't mean necessarily that you can. Remember, the camera always lies. See, look, I'm touching the box. No, I'm not. There's literally 1.5 feet of distance between me and the box and what I'm pointing at. This is a well-practiced procedure, by the way. This here, this here. We're going to look at this meter here and this meter here. And I practice this every day through the, well, YouTube. I'm scared of high voltage. It scares me to death. So please don't think for 1 minute that I am lax or flippant or take any of this not seriously, because this is literally, let's load the gun up and we're going to cock it and then point it at ourselves, and the only reason it's not going to go off is because nobody's touching the gun. Our operation light just came on. This has been a challenge to get this far. I'm here to tell you what. Zero signal. What zero signal means is a term that people describe to help us understand what mode of operation that we're in. The tube is in full cutoff right now, which means it's got a positive 23.5 volts applied to the tube that shuts the tube off. The tube isn't trying to amplify anything, it's just sitting there idling. The filament's lit, it's got plate voltage, but there's nothing going on with the tube because it's got the positive 24 volts on it. When we step on this pedal and we go into transmit mode, now we go to zero signal. We pull that 24 volts down to an 8 volt reference. On a 3500Z it's 5 volts, and we pull it down from 125 volts. Okay. Step on the pedal, zero signal. So the tube is now on and says, give me signal, I'm ready to amplify. Okay? To achieve this state has been a lot of time waiting for parts to show up, and then also a lot of time trying to get this in the rotation of things to look at. I know you guys don't understand because you don't see it on camera, but I am standing in a room right now that's probably got 500 pieces of other people's equipment, and I'd say probably 30 of those things are in different states of repair. Where either one, I'm waiting for parts, 2, I'm waiting for people to come up with the money to pay for the parts or the repair, or 3, they're waiting for me to have enough free time in amongst all the other things I've got going on to be able where I can rework something back into the schedule. I took a ton of time to focus in on this. Then I had to order parts, which immediately means it gets kind of pushed to the side, and then I've got to go work on things I have parts for right now. The supply chain is thus that it is a challenge to stay ahead of just the shortages on components to be able to maintain and keep doing repairs. This little guy here, these MPS 6514s, I don't want to say that they were hard to find because they were not, but they took forever to get. And then to actually get real ones, it took 3 different distributors to get real components. That's another problem that we're having with the Chinese market. The Chinese will print anything on a part to make a sale. It doesn't necessarily mean if it's the right thing. I had components show up here with the base emitter collectors backwards, the collector emitter bases backwards, or they just flat out tested bad. They were just something garbage that somebody had printed a number on because they saw somebody did a Google search for it one time and thought, we can make money off of it. I was actually able to find these parts from a guy in, believe it or not, Trinity, Alaska. Alaska, of all places. But there's a packaging, that's how I know. Needless to say, we had the right parts. We finally found the right transistors. That particular little transistor, which we're going to show to you here in a minute, is the switch that controls the foot pedal, that controls the bias on the bias board, but it has nothing to do with the actual keying circuit. But, we'll get to that here in just a second. It takes forever to get stuff. So this poor guy has been calling me and calling me. Dude, when's it my turn? Are you going to work on my box this month? I'll get there when I can, man. That's the only answer that I can give anymore is I'm doing the best I can. I'll get there when I can. I'm out here every day, 14 hours a day some days. 10 hours is a short day. Working on this stuff for you all. Every day. and there's no one really left working or even attempting to service this equipment left in the United States, for the most part. So bear with me, I'm slow as sin, but I always come through. This here has been a giant learning thing for me. If you go and look in the TenTec service manual, they'll tell you to go check 3 transistors for the bias. Well, I checked all 3 of those transistors out of circuit and they were working great. Put them back in the box, put them into operation, and they would fail. This little resistor will come into play here in just a minute. I have it sitting out here for a reason. Okay, let's show you what ended up actually being the crux of most of the problem. I have spent more time stuffed in this little hole than... The first thing that we're going to talk about is this right here. This is your positive 24 volts that feeds this whole amp. This right here, this red pin. This blue wire is where your bias comes in. Okay. So what happens when you step on this foot pedal is it takes 24 volts, actually 23.5 volts off of this board, and it switches that and it turns it into 8 volts when you step on the pedal. This is an isolation choke to keep RF from getting back onto the bias circuit, and it pulls down to 8 volts. Well, what was happening was 2 separate things, 2 completely separate problems. Okay, we're going to get a little technical here for a second, but I'm going to try and keep it as simple as I can. When you step on the foot pedal, we get a signal that comes into this board. It in turn trips this transistor, which then in turn drives this transistor, which flips everything else inside this board to give us that 8 volts. Okay? This transistor I tested, I must have pulled it at least 4 times. I thoroughly tested every diode, every resistor, pulled every transistor off this board and tested it, and everything out of circuit tested beautifully. Absolutely beautiful. Absolutely beautiful. I'm like, okay, problem's not here, shove it back in here. Then turn the amp on, and it would start pulling a ton of current. It wouldn't even get through warm-up mode, and the bias was activating, what I thought was bias. What was happening is this transistor was seeing a little bit of an electrical signal, was getting hot, breaking down. It'd go open, turn this transistor on, and it'd pull the bias on. Well, this is a 2-part problem. There was also a problem with these Chinese tubes, come to find out. There is something internally wrong, I feel was internally wrong, with one of these 2 tubes. And it was causing a bunch of plate current to be pulled. And it was taking and shorting this power supply completely out. The 24 volts that holds the tube at cutoff was going 100% to ground, and it was jumping. It was running back up through this blue wire, then back out through this blue wire, and then it runs to this center pin on the plug that attaches to the power supply. Well, let's go over here for a hot minute, and I'll show you what we're talking about. In the first video, I showed that this diode here was blown out on the power supply. Well, we replaced it with a 10A10, which should have told me to check other things down the line. Well, I did. When I realized I had a biasing issue, I realized that the bias on this box is a 23 volt setup. The reason it's a volt lower than the whole rest of the power supply for the amp is because it runs through a 1.6 ohm resistor, which is located down here. It is actually right here. It's right up here next to the edge of this capacitor. I don't know if you guys can see that or not, but it is there. And then, so you dump 24 volts. There's a full bridge rectifier that's right here, 4 diodes, D1s, D2, D3, D4. Okay. Otherwise, these diodes here. And I had to replace them because they were leaking. And they were also breaking down due to heat. Well, that feeds to that 1.5 ohm resistor. Now, the leads split. And what I mean they split, so let's go over here real quick and we'll look at the print for the board. Here's our rectifier bank. This is ground right here. This one here is ground. This is our hot lead that comes off our rectifier bank. Okay. Well, it comes up, there's then a series of resistors that act as a buffer, and they go off, and that's what runs the rest of the amplifier. Well, the circuit splits, and then there's a 1.5 ohm resistor that ties in here, and then it runs up, and then sitting here, right here, is a 6.8K resistor. Well, that in turn goes to this trace, which then takes off right here on an orange. It goes to a trace, and it takes off right here, which goes up to an orange wire. Well, that orange wire is, well, let's see. It's this orange wire right here. There's two of them in here. You have one here for the safety interlock, but then there's another one that takes off the board, runs up, and it comes to here on this trace. Well, the red and black wire that attaches to here, this is all one trace. It's got a capacitor, a diode, another capacitor, and two wires. This orange wire is what runs down, goes through that 6K resistor, then goes through the 1.5K resistor, and then goes to the rectifier circuit. The red and black wire, which is up here, attaches, the red and black wire attaches here, the orange wire attaches here. The red and black wire runs around and it goes to this gray loom that goes out and plugs into the back of the TenTec over here. So it comes out, comes into this plug and goes into the deck. Well, that red and black wire turns into the blue wire, which runs down this side of the cabinet. Then there's this big ball of silicone and the blue wire tucks in there. Well, what it does is they took, instead of having the slack just hanging out in here, they took all the extra slack and shoved it through a hole. So this blue wire doesn't attach anything. As it passes through the bulkhead, it goes and makes a big loop and then comes back right back out and attaches to this blue wire right here. This blue wire has now got 23.4, 23.5 volt positive circuit for this whole mess to switch. Remember this whole mess here? Well, there was a disc capacitor that sits right behind this inductor back here, right behind this inductor that I had to replace because it was burnt to frig up. There's a disc capacitors back here. It never occurred to me to pull a disc capacitor and I checked it, or to check it. So I pulled it and I checked it. Instead of being 10 nanofarads, it was 1.0 something nanofarads. And it would change as the component was cooling off, which told me the cap had broke down. So I replaced that disc capacitor. So that fixed the whole key foot switch issue, was changing that one little cap. But our biasing issue persisted, and it was this transistor. Well, I decided instead of me, I just assumed, because it's very hard to test this thing, because this is the air box for the entire amplifier. You put the parts in here that are going to control the shit in here, but you also got all the air going through here to cool the tubes. So you can't really test this and leave this plate off. Tube's going to overheat. So I assumed, me being me, I'm going to shotgun the shit out of this. So anything that had to do with the bias switching, I replaced it with brand new parts that actually tested. This transistor was the hardest one to get. This one was really easy. I got that in a couple days off DigiKey. This one here, it took a little bit of hunting. And this guy on eBay had some listed, and I ordered them, and they showed up, and they were the legit deal. So, dude, right on, whoever you are, thank you. But then we had another problem. With the tubes out, I could watch all of this circuit work. And I had one of my mentors tell me a long time ago when I was a kid, he goes, the amp does not care if the tubes are there or not. If you can create the circuitry to run around the tube and it all tests fine, and then you put the tube in and then you have a problem, it's a problem with the tube, it's not a problem with the amp. I'm like, okay, so I've now achieved my bias flop, I've achieved keying, I've got everything set up the way it should be. Step on a foot pedal, it's dropping down to about 8.2, 8.1 volts. I'm like, sweet, touchdown. I put the tubes back in, and we still have the problem on the front of the box. Let me close this back up. Well, no, wait a minute. We still have the problem on the front of the box. You turn the amp on, and the plate meter would come up to about 0.3, and then you'd lose all transmit function. And this would get pulled to 0. There's a problem inside the tube. I said, well, maybe this weak ass 1 amp supply they've got feeding this is a problem. Well, this red pin up here is a positive 24 volt for the whole box, and it's 8 amps. And I went, I wonder what happens if I force the tube to stay in cutoff. Just force the tube, because there's something wrong inside the tube. All the evidence now is pointing towards these Chinese tubes. How do I do that? I took this set of alligator clips and I went clip, and I went clip, and I turn the box on. And now there's like a 6 or 8 amp, 24 volt source pushing the tubes to full cutoff. And we went all the way through the warm-up procedure, and then the operate standby light came on, and I went, huh, and I stepped on the pedal. And I heard both tubes go plum plum, but still maintaining full cutoff. It stayed in cutoff. Well, that's interesting. So I turn the power supply off. High volts bleed off immediately because they're still in load on the circuit. I come back in here, I pull the jumper out, put the airbox cover back on, turn the amp back on, and it worked. It went all the way from, went all the way through the warm-up procedure. It didn't take off and start making its own power and try to operate. Everything worked. All the cutoff voltages and everything stayed. There was no more draw that was overcoming this abilities for power supply. Well, with the tubes being in a state of discombobulation, what it ended up screwing up, let's look at this side of the resistor. Look at that side of the resistor. You see something with the red band? You see on this one, see how it's red? This side is brown. The weakest link in the chain was that resistor, and it was going open. The tube was pulling the same amount of current from start. The problem was this resistor would get hot and then fall out of tolerance and quit passing voltage completely, negating everything else we had done here. I don't know what happened mechanically inside the tube to make it so that it works, but if for some reason you have this amplifier with these tubes in it and you turn it on, and within a couple minutes you hear the power supply start to hum real hard, and you look over and your plate amp meter is at 0.3, you're going to have to force the thing through its duty cycle to get the tube to settle down again, which means clip onto this bar, clip onto the tab with all the red wires on it, close the air box up, let it go through its full start procedure, shut it down, let all the high voltage come off of it, come back in here, disconnect these, put the air box cover back on, and I bet you'd be surprised. I bet you the thing comes back and runs. I say that too because I see it sitting here working right now on my workbench. This is going to work. We're going to make totally cool kick-ass power with this box here in just a second. But now we've got to get it from here to you, Mr. J. And the tubes are going to get shifted and moved around, bumped around in shipping. And I'm just saying, that's what I had to do to make this thing work. And it come down to the fact that we don't have good tubes, and I'm honestly of the opinion there's something wrong with the tube. But we figured out how to overcome it, and now we don't really have a problem. So let's go ahead. I want to put the cover on the power supply so we're somewhat safe. I'd sure hate to have something fall or drop into the power supply. So let me put the lid on this and let's run it through its paces. So the main goal here is to make this thing work. I am not selling this, or nor do I have to prove it works on all bands. I just have to prove that it works. Even though earlier tonight while I was on the phone with a customer, we ran it through all of its bands and we worked out how it worked, and it works well. Or what we're looking for is for this plate amp meter to jump up to 0.3. That tells us that we have a problem. Now, we just took and shifted the tubes and put them up on their side and set it back down and did a bunch of stuff. Still, the problem isn't presenting itself. It would normally take, this warm-up timer on this thing is like 3 to 5 minutes, right? Until we can get the operate light to come on. We're in wait mode right now. Normally take about a minute and a half or so, and then all of a sudden, darn, and if you watched it on a voltmeter, you could literally watch the 23 volts all of a sudden go down to 0. So it wasn't hard, but needless to say, we got her going on here. Let's zip over here and let's take a look at units of measure here. So we've got a 1,000 watt slug in peak, 1,000 in average, and a 5 watt slug. It's currently reading forward. Let's go ahead and flip that around. We're using the ICOM 7300 today as our driver. We're on 80 meters, of course. And I'm telling you, it's not going to do it now. I mean, that was driving me crazy. After all the work I'd done on the biasing circuit, because something was wrong there. And I'm telling you, it was presenting these problems without the tubes in the box. So once I got the whole circuit running right into the spec manual, when I put the tubes in, I went, man, there's something wrong. Because it immediately started doing weird shit that it wasn't doing with the tubes out. So I would not trust these tubes. I mean, you might get another 20 years worth of successful operation out of them, but my personal feeling about the Chinese tubes is they have not been the greatest for me in my universe. Not from what I've seen. Let's get the radio all set up. Dial the power down on the radio to, about 34%. Let's grab that microphone. Hello, 1 2 1 2 1 2. There, just went into operate. So, we're on AM. We're going to put 3 or 4 watts in it. That's literally 3 or 4 watts, making 200 watts of power. So we'll turn the ICOM 7300 up there to about half on AM. Now I'll turn it up to full. And we're going to tune by our grid meter. Okay, let's go ahead and we'll push the buttons on the ICOM and we'll go over to sideband. Let's see, menu, meter, there we go. Go over to sideband now. Hello, 1 2 1 2 1 2 1 2. So we'll go ahead and we'll hello, 1 2 1 2. No problem, right? Let's go on over here to 2x. So now the meter fully deflected to the right is 2,000 watts. Might have to tune it a little bit now. Hello. That's 2,000 plus watts with 100 watts going in. Now we're going to 5x. So we're looking at this middle scale. 10's 1,000, 20 is 2, 3 is 3,000, 40 is 4,000, 50 is 5,000 watts. Hello, 1 2 1 2. Hello, 1 2 1 2 1 2. But now look at what we're doing to the front of the amplifier here. Hello, 1 2 1 2 1 2. Yeah, that's the grid meter. And you see how we have that overdrive light going on? This is our output. Reflect, hello, 1 2 1 2. Forward, hello, 1 2 1 2 1 2. And of course, our plate voltage, hello, 1 2. But that light right there should scare the shit out of you. So let's go ahead and decouple this a little bit. Hello. Yeah, we're not going to get that to come down. We're putting too much drive in it. Let's back it down to about 70% power on the radio. Hello, 1 2 1 2. Okay, which reads over here. Hello, 1 2. Hello, 1 2 1 2. Like that. Hello, 1 2 1 2. Hello, 1 2 1 2. Hello, full legal limit plus a little bit. Hello, 1 2. Hello, 1 2 1 2. About 1700 watts. Now let's see if our meters up here in the front have settled down a little bit. Hello, 1 2 1 2 1 2 1 2 1 2 1 2 1 2. As we can see over here. Hello, 1 2 1 2 1 2. Hello, 1 2 1 2. According to the meter on the front, we're easily achieving full legal limit. Our grids are well below where they need to be, around 30, 35, 40, somewhere in there. Our plate amp meter is barely getting tickled. Hello, 1 2 1 2 1 2 1 2 1 2 1 2. Now, this guy has had this amplifier for, well, about as long as I've been alive, right? And he's talked on it every single day, 24/7, 365. He seems like he tells me on the phone. After talking with this guy on the phone, I have no doubt that he is totally capable of holding down a Q cell longer than this on whatever he wants to work on. Now we're playing with 80 because the amplifier can make power more easily down low than it can up high. Hello, 1 2 1 2. Hello. Here. Hello. Good old icon. No matter how loud you yell in the microphone, you're the same volume. 1 2 1 2. Audio 1 2. But we're not getting into that overdrive light. The point is, the amplifier is working. When it came in here, it was blowing up on command. And now we've got it working. And it doesn't matter what band we choose to go to, it will work there as well. Let's go to 40 and prove the point. Let's go here. We'll go 40. We'll go AM. Power level at 70%. Oh, what am I doing? Yeah, 80, 47. Yeah. Hello. All right. I'll go to sideband. Hello. 1. Hello. 1 2 1 2. Hello. 1 2. Hello. 1 2. Hello. 1 2. Hello, 1 2 1 2 1 2. Hello, 1 2 1 2 1 2. Hello, 1 2 1 2 1 2 1 2. We're still in the, by the way, we're still in the 5x scale. Hello, 1 2 1 2 1 2 1 2. Audio. Legal limit. Legal limit. Not murdering the grids. Hello, 1 2 1 2 1 2. All right, let's go to sideband. Upper sideband. Hello. 1 2 1 2 1 2. 1, 2, 1, 2, 1, 2. 1, 2, now we're on 10 meters. Hello, 1, 2, 1, 2, 1, 2. Audio, 1, 2, 1, 2. 1, 2, 1, 2, 1, 2. Now, my favorite thing about TenTec, other than they're really rugged, in this situation they're pretty delicate, but then if you give them good tubes, you don't have a problem. If you ever went to the factory, they would say, here's your amplifier, man. They would take a big wool blanket, they'd wrap it up all the way around the amplifier, they'd spool up about an 800 watt carrier and say, come on, let's go take a tour of the factory, supposedly. It's a story I've been told by many different people. Now, this could be I heard it from a friend who heard it from a friend who heard it from a friend. But I've got a guy here in town that's got one of these. He is hard on equipment. Hard on equipment. Like, hard on stuff. And he has broke his TenTec probably 5-6 times, but it usually comes down to him not understanding how to operate it. And once we taught him how to operate it, he quit breaking it, because the thing is just like a reliable tank. So I've always been a fan of these things. They were incredibly expensive when they were produced, but needless to say, here we are today, and this thing is fixed. I feel very comfortable saying here, your amplifier, Mr. J, has been repaired. It makes power. When you get it on your side of the street and you turn it on and that meter jumps up, you now know how you can go about fixing it. Just let it go through its startup procedure to where you get the operate light on with that jumper in play. Step on the pedal 2 or 3 times, shut the thing off, let everything bleed off and be at 0, pull that jumper back out, and the problem's going to go away. At least that's how I fixed it on my end, was overcoming whatever the defect was inside the tube. I would like to believe, in my mind's eye, I would love to believe that whatever the defect is inside of the tube, whatever little piece of shit or schmew that was floating around in the inside of that tube, we burned it off and we don't have the problem anymore. I don't know. Not an American-made tube. And we have no one that we can go cry to about it. Like, we can't say, hey, it's not right, it's not working right, the problem's with the tube. We don't have that. We don't have that option. So I can tell you this, all of this is because we didn't know how to read this meter, I feel. When the tube started to go bad, you should have just shut the box down and got new replacement tubes instead of running them until there was nothing left. But if you don't know, you don't know, and it's not a big deal. Problem is solved, problem is fixed. And boy howdy, am I going to be glad to have all of this gone for my little universe, and you're going to be back on here and you're going to be having fun. So on that note, I'm pretty excited. You got a brand new power cord out of the deal. You got brand new glitch resistors on the high voltage side up here and over in here. You got brand new rectifiers for your 24 volt bias control and power supply for the amplifier. Your fan switch was repaired, amongst a myriad of other little things that we found that the tubes all affected when they shorted out and went to ground. So I'm excited. This thing's gone. It's done. It's dealt with. I'm happy. You're going to be happy. And gentlemen, I appreciate you tuning in to watch me conclude this video, or conclude this one amplifier. I've yet to have one kick me in the ass. Well, no, I take that back. I had a Chinese knockoff amplifier one time beat my asshole in, and I couldn't figure it out. Just couldn't figure it out. I sent it back to the customer. Sorry, man, can't fix it. So, other than that, let's see, that'd be 3,000, almost 4,000 boxes ago. So, my record is 4,000 and 1 failure. I'll consider that a win. I sleep pretty good with that record out there in public land. Gentlemen, I'll see you. My name is BBI. Big shout out to Sigilant, MechMan, Excess Power, Bird, Coaxial Dynamics. Thank you to all my Patreon users, supporters. And a big thanks to all of you. Off to the next headache. God, I love these challenges. I'll see you.